Good evening, everyone. Welcome to Learning Competitive Programming with CodeChef channel. So, just a quick introduction of myself before jumping into the problem. I'm Manwani. You guys might know me as resource at codeforces.com, where I'm currently All India Rank 2, or NM at codechef.com, where I'm currently All India Rank 2. Just sorry, sorry for that. So I have recently also joined the an academy platform as an educator. This is my profile, where I have taken some special live classes, or I'm going to take the number 3 course. You can also check that out if you are interested in that. So I'm going to discuss the whole flow of this session. I'll be first discussing the problem itself. Try to understand what the problem means. Then I would try to explain the concept or the algorithm required in the problem. And then I would implement that problem to show how it's coded. And then after that, I'll be taking all the doubts after all of this completed. All of this is completed. So if you have any doubts, please wait until the end of the lecture to ask me them. So let's jump into the problem. This problem is called a balanced game, and it was in Cook Off Division 1, this September Cook Off. Here, two of your friends, let's denote them by P and Q, are playing a game and you are acting as a dealer. The rules of the game are as follows. There are n bracket sequences denoted by S1, S2, etc. to Sn. Initially, both players do not have any sequences. They play up to n turns. For each valid I, the ith turn, you have to choose one player and give the bracket sequence Si to this player. So you are like taking all of the strings one by one and choosing, yeah, this should go to P and this should go to Q, etc. After each turn, if it is possible to arrange all the sequences of one player in some order and concatenate them in such a way that the resulting bracket sequence is non-empty and balanced, that player immediately wins and the game ends. Note that it is impossible for both players to form non-empty balanced sequences at the same time. This is an obvious line. So what this line means is when you are giving out the problem to each player, well, let's say you're giving out a problem to P and you're giving out to problem Q. If currently P can reorder his strings in such a fashion that it results in a balanced string, because these are all bracket sequences. So in what we mean by balanced is a balanced bracket sequence, right? So if it happens so, then P is going to win. We like P more, and hence we want P to win. Find the smallest number of turns you need in order to make P win, or determine that it's impossible to achieve this. Here is the definition of a balanced bracket sequence, which I'll be explaining after this. Here's the input. There are some t-test cases. The single integer n denoting the number of strings in the strings here. In the output, you just have to output what is the minimum number of moves you have to make, or output -1 if it is impossible to do so. If it is impossible for P to win, then let's take a look at the example input by which we can understand like what the problem is trying to say. So we have one test case, 4 strings here. This is the first string, the second string, the third string, and the fourth string. These are all brackets sequences with opening brackets and closing brackets only. The output is 3, which means we only require the first 3 strings to make P win. And the explanation is like you can give S1 to Q and S2 and S3 to P. So basically we are discarding S1 as a garbage disposable to Q because we don't want Q to win. And then we're giving S2 and S3 to P, and he can just arrange them in S2 first and then S3 second fashion. And that would just make him win because it is a balanced bracket sequence. So let's discuss what this problem is about and try to reduce the problem first. So let me just share my screen. here. So in this problem, let me just first we are going to reduce the problem. So in the example input, as it was like what the first string was, I don't remember what the first string was, but we were giving it to Q as a way to dispose it because we don't want to give it to P. Then the second string was 2 opening brackets, and the third string was 1 opening bracket and 3 closing brackets. We gave this to P, and P just arranged them like this, and now it's a balanced string. So what can be said here is let me define a special subset first. What is a special subset? So we have the whole set of strings S1, S2, S3 up until Sn. A special subset is something S which comprises of some strings from our initial set, and it is also defined as we can reorder these strings to make it a balanced bracket sequence. Now, this is very important. That's why I'm taking so much time on it, because I'm going to use this definition again and again. Special subset is a subset of some strings which we can reorder to make it a balanced bracket sequence. Like in the example, we had 4 strings, whatever the first string was, then the second string, and then the third string, and whatever the fourth string was. I don't remember. So this is a special subset because this can be reordered in some fashion to make it a balanced bracket sequence. So what our question wants us to ask is, we are still reducing the problem. I'm trying to write it in mathematical form so we are able to understand the question properly. That we have to find the lowest x such that there exists a special subset in S1, S2, Sx. So in this set, if there exists a special subset, then we have got the answer, which would be x. Why is it so? Because for the special subset, let's say the special subset is something like this, S2 and then S6 or whatever, Sx would be there as well. So we can give all of these strings to P to make him win, because he can then reorder the strings to make a balanced bracket sequence and give the rest of the strings to Q. Now, the important thing that one might be wondering here is why can't Q win here? Because I'm giving these strings to P. So when I'm discarding the other strings to give to Q, can't there be a case that Q can win? No, there can't be, because we have said the X is the lowest number. The strings that we're giving to Q would be x minus 1, would be less than x minus 1. So if there exists a special subset there, then it's not the lowest x. We have got a lower x in which we can find the answer. So it's a contradiction. That's why this is the reducement of the problem, that we have to find the lowest x, that is there exists a special subset in S1, S2, etc. to Sx. This is the reducement. Now let's go forward to like understand how to find this x. So the term, the buzzword here is binary search. You might have guessed it already that this problem would require binary search, but why binary search? First of all, it satisfies the binary search property. And what is the binary search property? That if S1 to Sx does have a like special subset, then for any y greater than x, S1 to Sy will also contain a special subset. And for any y less than x, S1 to Sy will not contain the special subset. So here's a condition when the starting, let's say x minus 1 elements are displaying no, that it doesn't contain a special subset. And then the rest of the elements are displaying that yes, S1 to Sx does contain a special subset. So this is a standard equation where, just wait a second. This is a standard binary search property. If it's any problem satisfies this, then we can say that yeah, binary search would work on this problem. So our problem further reduces into given some strings S1 to Sx, does it contain a special subset? If we can find this out, then we can just binary search on the x property, and then we can just find out like which is the lowest x that we are talking about. If in case you forgot what special subset is, it's just a subset which we can reorder to make a balanced bracket sequence. So in this problem, let's try to reduce it further. How to know a subset is special? This is the most basic problem that we can reduce from this problem. I'm just trying to vocalize my thought process that went into my mind when I was solving this problem. First, I got to know that, yeah, I'm going to use binary search into this. Then the binary search question was, given this, does it contain a special subset? Then I try to reduce it more. So how to know a special subset is special? So this is a pretty standard question, which is given some bracket sequences. S1, S2, Sn, etc. Can it be reordered? To make a balanced substring, to make a balanced string, sorry, to make a balanced string, right? So given some bracket sequences, S1, etc., S2, etc., up until Sn cannot be reordered to make a balanced string. Example, let's say we take once S1 is equal to this, and then S2 is equal to this, this, and then S3 is equal to this, S4 is equal to this, this, this. So this is a case where we can reorder them to make it a balanced substring in the fashion where we are going to do S4 first, then S1, then S2, then S3. So that would make 4 opening brackets for S4, then a single opening bracket for S1, then 3 closing brackets and 1 opening bracket for S2, then a single closing bracket for S3. So this would match up with this would match up with this would match up with this, and well, yeah, like this is not a balanced substring, but let's say if there were 2 more closing brackets here, then this would match up with this and this would match up with this. So this is a balanced string. So we want to know, does S1, S2, S3, and S4 make a special set? Can they be reordered to make a balanced string? So can they be ordered to make them special, to make them balanced? So for this purpose, now I'm going to discuss about how to reduce a string that you have been given, like just a bracket string, like a string like this. Let's say. So how do you reduce it? How do you turn it into numbers so that you can play with them? So the idea here is, first, we can store the number of opening brackets minus number of closing brackets. Right, that is one number. I like to call this delta, as this is by how much the sequence is putting emphasis on a whole string, right? So this is called delta. I'm going to be calling it delta from now on. And the second variable that's important to classify this whole string as just number is how many opening brackets are required to apply this string. And what do I mean by apply? I'm going to be discussing what do I mean by apply. So let's take a smaller example. Let's take just this string. This is the example. So before we can use this string to make a balanced string, we have to apply some opening brackets here, after which we can apply the string here. Basically what I'm trying to say, if this string has to be used in a balanced string somewhere, what is the position, like what is the delta that was required prior to this to apply the string here, to position the string here. There should be some positive delta that must have come back here, which is like 3 in this case. After 3, this string can be placed here. Before 3, this string cannot be placed here because it would not be a balanced string after that. In the editorial, it is written properly as let's take bracket sequences, and then just eliminate any pair of opening and closing brackets which are adjacent. So we eliminate this. Any pair of opening and closing brackets which are adjacent, we eliminate this. Then it will result in always some number of closing brackets first, and then some number of opening brackets, right? It would always result in this. This can be some, let's say, x greater than equal to 0, and this can be some, let's say, y greater than equal to 0. We are eliminating this pair of adjacent opening and closing brackets because they will not be relevant to the placement of our strings in the balanced string, because they do not play a role in any of the stuff that's going to come. So here's some x greater than equal to 0 of closing brackets, and then some y greater than equal to 0 of opening brackets. And the delta here would be y minus x. And the required delta, which I was talking about here, the second number, how many opening brackets are required to apply the string, let's call that required delta. That would be x. So this would be delta, and this would be required delta. And these two numbers, y minus x and x, or delta and required delta, can be used to identify any balanced string. We not identify completely, but only these numbers are required if we are going to use them further in our algorithm. Not any more numbers are required. So we are just going to when we start storing these strings, we're not going to actually store the entire strings. We're just going to store what is the delta and what is the required delta. All right. Another way to like imagine this is, let's say you have a graph, and for every opening bracket, let's say I have an opening bracket here, you go up by one distance, and for every closing bracket, you go down by one distance. So whatever string you have, right, you go up, up, then down, then up, then down, then up. So this would result in a line graph, something like this, right? Further continuing on. So delta is basically whatever this height is, whatever the end of the string is, this is called delta. And whatever the minimum depth is below the axis, that's the required delta. All right, because this many opening brackets are required prior to applying the string, so that we can actually use them in a balanced string. And delta is just like the number of opening brackets minus number of closing brackets. So why did I talk about this all? Because I'm going to be using this in the question that I asked before, which is how do we know that a set of strings can be reordered to make a balanced string? So the algorithm to check this is greedy. It's a pretty known greedy algorithm, which does this by classifying the strings in 3 sections, which is the positive strings, which have delta greater than or equal to 0. The 0 strings, which have delta equal to 0. And then we have the negative strings, which have delta less than 0. Right? And the reason for classifying them into these three categories, which is pos, 0, and negative, is that we can always, place these strings in this fashion as well. That, which means like we can first put all the positive strings first, and then all the 0 ones, and then all the negative ones. How do we place the positive strings in itself is a question, but like if there is a solution which has, let's say, positive, positive, then negative, then positive, then negative, then negative, and by this positive I mean a string which has greater than 0 delta. So we have a positive delta string, then a positive delta string, then a negative, then positive, negative, negative. So we can just switch these positive and negative strings in by themselves. So it would result in positive, 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 negative, negative, negative. So there always exists a solution of positive, 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 negative, negative. Basically, there always exists a solution in this fashion where we have first put positive, then 0, and then negative. If there exists a balanced string, right? And if there doesn't exist a balanced string, then there wouldn't exist a solution in this fashion as well, right? So we can always put them first positive, then 0, then negative. The next question is, how do we order the positive strings in themselves, right? How do we order the positive strings by themselves? Question, like we have to sort them according to the required deltas, and I'm going to explain why, but that is the algorithm. Sort them by their required deltas, and then see, can we place the strings in this fashion by themselves? So we have like string 1, which have delta as a1 and required delta as b1, then a2, b2, a3, b3, etc. We can apply the a1, b1 string only if b1 is less than or equal to 0, because if it is basically greater than 0, then we can't place it in the first position, right? Because it requires a delta of greater than 0 to place that string somewhere. And the required delta b2 should be less than or equal to a1, because there's a string a1 that has come before. Then b3 should be less than or equal to a1 plus a2, because that is a delta at that point, at this point. The total delta is a1 plus a2. So here the delta is a1 plus a2. Just give me a second. So because of this, like b1 should be less than or equal to 0, b2 should be less than or equal to a, b3 should be less than or equal to a1 plus a2, and so on. And we know that a1, a2, etc. are positive, because we are only trying to order the positive strings currently. So if there, so we can just sort the strings by their b values, like the b1, b2, and b3. This should be in increasing order, right? If this is possible, if this string is possible to make, if these conditions are being satisfied, b1 is less than or equal to 0, b2 is less than or equal to a1, b3 is less than or equal to a1 plus a2. If these conditions are being satisfied at every point, then yeah, we can order these positive strings as like this. If they are not being satisfied, then we can't order them like this. All right. Then the 0 strings, let's check out what happens in the case of 0 strings. In case of zero strings, we can just place them in any order. It doesn't matter. We just have to check. Let's say their deltas would be zero. Let's say their required delta is B1 and let's say B2 and then B3. We just have to check that B1 is less than equal to whatever the delta we have currently, like whatever delta we have come after, uh, adding up all the positive strings. And B2 is also less than equal to current delta, etc., etc. Right? And in case of negative strings, we just have to do the opposite of positive strings. And what do I mean by positive? The opposite of positive. It's like when I gave the graph analogy. If we're trying to see a positive string from this side, which is like this, let's say this is a negative string. We saw the positive string from here, but because this is a negative string, let's say this is a negative string actually. So this is the required delta, and this is the delta that was caused, right? So in case of negative strings, we have to switch our axis, we have to switch our perspective. We are trying to see the strings from here now. We are basically in positive strings, we were trying to apply the strings from the start of the string. We are trying to apply the first string, then apply the second string. In negative strings, we are trying to apply the strings from the last, then the second last, then the third last, and so on and so forth. So here, the delta, the new delta, would just be the negation of the previous delta, and the new required delta would be the previous delta required delta minus absolute of delta, which means required delta plus d. If you want to see it in the fashion of, let's say, the x closing brackets and the y opening brackets one, so we have x greater than 0 closing brackets and y greater than equal to 0 opening brackets. So the delta before was y minus x, and the required delta before was x, but now the new delta would actually be x minus y, and the new required delta would be y. And this is exactly what I'm doing here as well. If you just put the values of d in these equations, then these equations are actually going to be the same. So what I'm doing is just trying to see from the last of the string and not the first of the string. All right. So if in this fashion, all of the strings like this can be ordered, like the positive strings can be ordered, and in case of negative strings, we're trying to do the opposite of positive strings, and they can be ordered as well, and the zero strings can be ordered, and the total cumulative delta that we have achieved is actually 0. Then we can order the strings to make out a balanced string. So the things we have to check is first that their total delta must be 0. The second, that we are applying them in positive, then 0, then negative. And then third, in positive, we are sorting them according to the required deltas. Similarly, in the negative ones, and in zeros, we are just applying them anyways. If these strings can be ordered in this fashion and still make a balanced string, then yeah, we have made a balanced string here. If not, then they cannot be made into a balanced string, no matter how we order them. All right. So this was a subtask which we're trying to do. The next subtask is how do we know a set which was like S1, S2, etc. up until Sx has a special subset. Up until now, we were trying to see is this set special or not. Now we're trying to see if this set has a subset which is special or not. Let me just write it down first. How do we know a set S1, S2, etc. has a special subset? So the algorithm that we're going to use here is very similar to the algorithm that we used in the previous section, which is like if we have to know if this contains a special set, then the algorithm that we used was to first place the positive, then zero, then negatives. Pretty similar here. We're going to first reduce all of the strings in delta and required delta form. And then we're going to classify the strings in positive strings. So there will be a set of positive strings. There will be a set of zero strings. And there would be a set of negative strings. Right? So this would contain SX, SY, SA, SB, SZ, SR, whatever. Right? So how do we know that we can pick some strings from this total set and make a special set? And that is seen by, let's first try to see what the zero set means. So in zero set, there would be some strings of the fashion 0 comma b. This is the delta, and this is the required delta. So if b is equal to 0, if any string exists where the required delta is 0, then this string is actually balanced in on itself. A balanced string has a delta of 0 and required delta of 0 as well. This is a balanced string. So coming back to the game that was in the question, we can just give this string, which has the 0, 0 delta and required delta, and just give this to P, and P would win at that point itself, because he's going to say, yeah, I do have the string and this is balanced in or itself. So I don't have to do anything else. So if it contains a string of the fashion 0, 0, then yes, this whole set contains a special subset. We're going to say, yeah, it's going to contain. But the rest of the zero strings, if it doesn't contain a 0, 0 fashion string, if all it contains is 0, b, where b is greater than 0, not greater than equal to, just greater than 0, then we can just ignore these strings, because these aren't going to be useful in our algorithm, because this doesn't really affect our algorithm in any way. These are just going to take a delta and not increase a delta, not decrease a delta. It's just going to be there without doing any actual purpose. You might understand more of what I'm talking about next, but these strings wouldn't be useful. So we have eliminated the zero set completely. That is, if it contains a 0, 0 string, then yes, we do have a special subset, which is this string. And if it doesn't contain a 0, 0, then just remove all of the other strings that the zero set contains. Now, how to see in positive and negative strings? So positive set and some negative set. This would contain some, let's say S1, S2. This contains some Sn, and this contains S dash 1, S dash 2, etc. S dash n. Right? So let's focus on the positive set first. We're going to define an array, or a function rather, which is fx, and that is, can a subset of positive be reordered to make delta x, right? So if we can find out this value, can can a subset of the positive strings be reordered to make the delta X? Then we also know for this the similar thing for negative as well. The similar things like, let's say, f dash x, entirely same thing to make delta x. So if both of these things exist, right, which would be in the form of true or false, right, it can be only true or false. If a subset exists, it would be true. If it doesn't exist, it would be false. So if for some fx where x is greater than 1, if for some fx x is greater than 1, x is greater than 0, sorry. If for some fx x greater than 0, fx is equal to f dash x is equal to true, then we can make a subset of the positive strings to make a delta x, and we can make a subset of the negative strings to make a delta x, and then we can just apply them side by side to, let's say, this is the positive one, this is the delta x, and this is the negative one, and we have got a special string. We got a like balanced string. So yes, if for some fx x greater than or equal to 0, fx is equal to f dash x is equal to true, then we have got the answer that yes, it can be, there can exist a special, this set contains a subset which is special. But if it doesn't exist, doesn't exist anything like this, then no, it doesn't contain a special subset. So how to make the fx function? It is a simple DP, like sort the strings by their required delta first. The DP state would be the DP states, let's say for I and J, they sort the strings, then the sorted string would be something like S1, S2, S3, etc. up until Sn. So dpij would be, can delta j exist from the first I strings, right? This is a pretty standard DP that we use in many questions. From the first I strings, can we make a delta j from the first I strings? The base cases here would be DP 0, 0 would be true, but DP 0 of any A where A is greater than 0 would be false. These are the base cases. Because the empty substring, we, the empty substring has a delta 0, so dp00 is equal to true, but anything other than that is false. And then the recursive step is dp I'm j is true if dpi minus 1j, like if we can make delta j from dpi minus 1, the first I minus strings itself, then we don't require the ith string itself. So we can just type like, yeah, it's true because it was making j delta from the first I minus 1 string as well, right? If dp I minus 1j or dp I minus 1 j minus, what would be the delta that we are adding here? It would be, let's say, si dot delta. But the special thing that is required here is where j minus si dot delta must be greater than equal to si dot required delta, right? Because if this stuff is not greater than si dot require delta, then we can't place this string itself here. So j minus si dot delta should be greater than si dot require delta, and this dpij would be true if dpi minus 1j or dpi minus 1 j minus si dot t. Else it would be false. Right. So this would be the dp that's required in the last part. From this dp, we can find out like fx, which would be just dp nj, right? Fx would be dp nx, and then we can find out like if this set contains a special subset or not, and then we can apply binary search on that function. And then once we apply binary search to the function, we can find out like what is the lowest number of moves we require for p to win. So this is the whole algorithm. I'm now going to try to code this algorithm. Let me just switch my screen to Visual Studio. So this is my Visual Studio. Let me know if the font is not visible or anything. I'm going to be coding in C++, but the idea will be the same. You can code it in any language you want. Let's start by declaring int main. I'm just returning 0 first. So we would have some test cases, which I'm going to be representing by C. And we are going to, for each test case, we're going to take the number, which is n, the number of strings. Then for each string, we're going to take in a string. But as I told you, we are not going to store the entire string. We are just going to store the delta and the required delta the string requires. So let's make a pair of int comma int for that. And this would be delta comma required delta. The d dot first would be the required delta. D dot first is delta. Sorry, and d dot second is required delta. How are you going to build that? Di dot first is equal to 0, and basically di is equal to 0, 0 initially, and then for each character in our string, if C is an opening bracket, we are going to increment di dot first, else we are going to decrement di dot first. We want the minimum with required delta. So di dot second is equal to maximum of di dot second, the depth we are currently at, which is minus di dot first. This would build up the whole delta and required delta of all the strings. Let's get into the binary search part. It is int l equal to 0. L is equal to 1 because you would require at least one string, and r is equal to let's say n currently. I'm going to change the r, but let me just code the rest of the part first. X is equal to l plus r by 2. We are going to do the binary search here. For x is equal to l plus r by 2, we are trying to see is s1 to sx be able to make a special string, and does it have a special subset rather. So does it have a special subset? For that we need to classify them into first positive and negative. So we're going to deploy two vectors of pair int comma int. positive and negative. For int I equal to 0, I is less than x, I plus plus, this is going to iterate on the first x strings. If di dot first is greater than 0, then we are going to just positive dot push back di. Else if di dot first is less than 0, then we are going to push this into the negative vector. But the important part here is we're going to change it a little. Like I said, we have to make it into new delta. The new delta here would be minus di, and the new required delta would be di dot second. Here it would be di dot first. Sorry, minus di dot first would be the new delta, and di dot second plus di dot first would be the new required delta. Right. So this is how I'm going to convert negative strings into positive strings, so we can apply the same algorithm on both of them. Right. Else, if di dot second is equal to 0, and by this, what do I mean? If it's di dot first greater than 0, else if di dot first less than 0, this takes care of the positive and the negative cases. The only case remaining is when the actual delta is equal to 0. And if in that case, what we talked about was, if the required delta is actually 0, then we know that yes, it does have a special subset. And if it's not 0, we're just going to discard it. So in this case, let's initiate a Boolean value here. Any special subset. Currently it's false. And we're going to make any special subset is equal to true here. Right? So here it's directly any special subset is going to be turned to true. Then next, we are if any special subset is currently false, or without that as well, we are just going to like deploy the DP. And for the DP, we are going to use a vector DP for pause, vector int DP pause. And I'm not going to actually create the 2D DP because the same work could be done in a single linear DP as well. I'll explain how I'm doing it. DP neg, and I'm going to push back true in both of them, which is the base case, because DP0 should be true. Then sort the positive strings according to the required deltas, as I talked about. So it would be pause.begin, pause.end, but it would require a special comparator because we're going to sort them according to the second element, not the first element. So let me just write the comparator over here. The bool comparator, it would contain pair int comma int and a, and pair int comma int and b. If you're confused by what am I implementing, try to read like how the sort function in C++ works. And basically in C++, you can give any custom compare functions that you want with your sorting, and that's what I'm doing here. So a dot second less than b dot second. So my whole array will be arranged in this fashion, where every initial element has less required delta than the second element, right? And similarly, I'm going to do for negative as well. Then I'm going to write the code for positive. So for positive, I'm going to go through each positive string. Let's that be it, and for int I is equal to currently whatever the height of the dp pause is. It is dp pause dot size minus 1. And this will be greater than equal to the required delta, because it cannot go lower than the required delta of the element, because like I said in the whiteboard, let me just write this down first, then I'll try to explain what I'm trying to talk about. So here it will be it dot second and I minus minus. For if here dp pause I is 2 right now, so while there will be another function here while dp pause dot size is less than equal to it dot first I plus it dot first, dp pause dot pushback false, and here dp pause I plus it dot first is equal to 2. So what I'm trying to do here, I talked about 2D I converted into a linear DP. What is this? So here DP pause, I'm directly trying to build the fx function that I talked about. So initially the fx function has only a single element, which is f0 is equal to true, because I have not considered any of the strings that are going to come. And then when each string comes, what I'm going to do, I'm going to update that fx function so as that it's always, always permanent, like the fx function is updated every time with each string. So for a particular string, it, where it dot first it is delta and it dot second is the required data, to push this into the fx data structure, it dot second I should be greater than equal to it dot second, because from the current delta I, I'm trying to insert the new string, which is it, right? So from current delta I, the I should be greater than the required delta of the next string, it dot second. And it can be from int dp pause dot size, because that's the latest true that has come, right? And if dp pause I is true, then we're just going to dp pause I plus it dot first is equal to true, because we're going to apply the string here as well, and then it can go to the next step. But the loop that I applied here is just to make sure that the size of dp pause is consistent, so that we can apply this operation, right? So this is the complete explanation of what I'm trying to do here. Similarly, I will do it for neg and dp neg. What I'm just do here is just find pause. Wait a second. Just in the selection and replace it with neg. So dp pause and dp neg are completely built now. They represent fx and f dash x respectively. And for int I equal to 1, I is less than whatever the minimum of these two values is. dp neg and dp pause, whatever the minimum of these two values is, and I plus plus, if any of these both of them are true, like fx is true and f dash x is also true, that means if dp pause I and dp neg I, then we are just going to is special the boolean value that I declared first, a special subset. Any special subset, I'm going to make it true, because fx is true and f dash x is also true. So if any special subset is true, then we're just going to do r is equal to x, because Now I'm going to explain how my binary search is working. The L R variables are the range in which my answer can be. So my answer can be currently in L to R. We have seen that yes, there does exist a special subset from up until X. So we're going to update R is equal to X because the minimum value that we require is less than or equal to X now, right? So R equal to X. Else that there doesn't exist any special subset here. So L is equal to X plus 1. Another important thing that I want to talk about here is, wait a second, why is it showing an error? Yeah, I put a comma here. So another important thing, I have declared from L equal to 1 to R equal to N. What if there isn't any special subset, like it's impossible for P to win? So to handle those cases, I'm going to actually declare R is equal to N plus 1. And if at the end of the binary search, if L is equal to R is equal to N plus 1, then we know that uh, it is impossible that P cannot win. So if L is equal to N plus 1, then we had to output minus 1, I think, that it's impossible. Else we just output the L that we have got. And after each line, we put a separate new line after each test case. Let's try to see if this works or not. Yeah, it's working for the test case. It's giving 3. I'll try to give a stronger example, which is, let's say, I have one test case, 4 strings here. A string like 2 closing brackets and then 3 opening brackets. Then I got another 3 opening brackets. Then I got 3 then I got another closing bracket. And then I got something like this. It's showing minus 1. Is it showing that? Yes, because yes, there doesn't exist any special subset here which can make it like make P win. So like I'm just going to submit that on CodeChef, and then I'm going to take your doubts. Let me share my screen to the Chrome tab, CodeChef. Here, submit as practice. Let me copy the code. It shows the correct answer. So if you guys have any doubts or anything that you would like to ask me, ask it right now. Why can't we solve it using stacks? Because the stacks are used at a very basic level in strings. Let me just share my screen in at the whiteboard. I try to explain where is stacks used. It's generally used at a beginner level. This is a little advanced than that. So when we are using stacks to handle bracket sequences, what we are trying to do is put this and then this. Basically, we do have a stack, right? And whenever we do have an opening bracket, we put this in here, and to have another bracket, we put this in here. And then we have a closing bracket, so we eliminate the last opening bracket, and then we have, let's say, another opening bracket, then we insert another opening bracket here. and we continue to do this, right? Uh, I'm doing the same kind of thing in uh, totaling of the delta and the required delta. What I'm doing here is whatever the string that I had initially, it might not be a balanced string, but I'm trying to see what is its delta, like what is the opening brackets minus closing brackets, like what is the stack size after this algorithm is finished, right? That would be my delta. And the required delta is something like, let's say we have a closing bracket and an opening bracket. So if we apply to, use this string in the stack algorithm, then initially we don't have an opening bracket, then we can't use the closing bracket to eliminate the opening bracket. So how many opening brackets are required initially so that this string doesn't cause a memory exception here? That's called the required delta. So I'm using the concept that we learn in stacks in a better fashion in delta and the required delta numbers. But it's a very advanced topic. We could have used tags anywhere in our data structures, but it wouldn't help us that much. Any other doubt? How much time did it take you to become a wonderful 7-star coder on CodeChef? So this is like about me. Uh, so I was expecting some relevant topics to the problem itself, but let me answer this in a 2-minute answer. So basically, I started competitive programming in my first year. I'm currently at IIT Guwahati, currently studying at CSE, and in my first year, like my seniors urged me to start competitive programming because it's required in the world of programming to get a good job or get into interviews and stuff like that. So I started that and I instantly got into love with it. Currently, I'm getting into my 3rd year, so it took me around 1.5 years to complete that. If you please do fill the feedback session to let me know if how do you like this lesson, and would you like to see some improvements? What would you like to see here? So in the description down below, just fill the feedback form, and if you do have any doubts for me after the session, you can just message me on Codeforces or message me on CodeChef discuss, or approach me at an academy, wherever you want. For a beginner, can you suggest a good resource on STL? Yes, there's actually a very good resource on STL. It's just search STL on Google, and the first link that comes up, right, is like a complete. I don't remember what the site was called, but is the first link, I think, and it has the entire vector. It contains it, and it also contains the time complexity and whatever you need to understand it. Also, STL is a topic that you shouldn't be focusing on like too much, I would say, because it is a topic that requires you around a week to complete. So you shouldn't ponder upon which resource is good to learn STL. You should just get into it. Like when you learn C++, you weren't sitting which is the best resource to learn if-else statements. If-else statement is so basic that you can just learn it from any site you want. Similar is STL. You just have to get into it and not focus on the which resource is the best part. Any more doubts? Just ask them out in the chat. All right. Uh, like I said, if you have any other doubts, you can approach me at an academy or give me a message on CodeChef Discuss. I would be ending the session here. Please do fill out the feedback form to like let me know if I performed good, if this was enjoyable and a learning experience for you. And this is it. We would be now ending the session. Goodbye, you all, and I hope you enjoyed this.